Good day, students. Welcome to Mathgotserved.com. And this clip, we're going to be going over question number 6 of the 2018 AP Calc full response question, and it focuses mainly on implicit differentiation. All right, question 6a reads, consider the curve given by the equation 2 quantity x minus y equals 3 plus cosine y. For all points on the curve, 2/3 less than or equal to dy dx less than 2. Show that dy dx is equal to 2 over 2 minus sine y. All right, so let's go ahead and do this. So we want to show that the derivative dy dx of this equation that we have right here is 2 over 2 minus sine y. Okay, we're going to be using implicit differentiation. Now, the first question is, how do you know that we're differentiating implicitly? If an equation is not solved explicitly for the dependent variable, y in this case, and you have to differentiate, then it's implicit differentiation, okay? All right, so before we get started, let's get rid of this parenthesis. So we just distribute the 2, so we have 2x minus 2y is equal to 3 plus cosine y. So you might wonder what's the benefit of implicit differentiation? Well, implicit differentiation is helpful because some equations are extremely difficult to isolate the dependent variable. So in this case, for example, if you want to solve for y first before you differentiate, it's going to be almost impossible to do that algebraically, okay? All right, so let's go ahead and differentiate implicitly, and then we'll get dy dx isolated. So we're going to differentiate both sides with respect to x, which is very important. Please pay attention to what you're differentiating with respect to anytime you're carrying out implicit differentiation, okay? All right, so what does it mean when we say we're differentiating with respect to x? Well, it basically means that when we're differentiating a term, if it's a function of x, then there's agreement, and then the dx cancels out. But if a term we're differentiating is another variable other than x, there's going to be disagreement, and we'll have d of that variable dx. All right, let's go ahead and take a look at what that looks like. When you differentiate 2x, you have 2. Derivative of 2x is 2. We have agreement here, so it's going to be 2 dx dx. Okay? What does dx dx simplify to? 1. Gone. Okay? But 2y, the derivative of 2y is going to be 2, but we have disagreement here. Y and what you're differentiating with respect to differ, so we have to apply the chain rule. We have dy dx. It doesn't cancel out. Okay? So this indicates disagreement. Agreement doesn't have any infinitesimal components associated with it. All right, applying the same procedure to the right side of the equation. The derivative of a constant is 0 with respect to anything because constants do not change. We have another disagreement here. This is a function of y. So let's differentiate this. Derivative of cosine is negative sine. All right, since we have disagreement, we have to differentiate the dependent variable with respect to x, dy dx. Okay, all right, so let's make this look pretty. We have 2 minus 2 dy dx. I'm going to simplify the right side, okay? Equals negative sine y dy dx. All right, so what we're going to do now is just algebra. Okay, what am I talking about? Well, the goal here is just to solve for dy dx. That's all you're doing is algebra, okay? Okay, so let's go ahead and do that. We can, let's see what we want to do here. Well, let's add negative 2 dy dx to both sides, okay? Because if I look at the desired form, we have the constant and the trig function and then minus. So let's do that. So I am going to proceed to, this is just algebra, okay? I'm going to add 2 dy dx to both sides of my equation. Okay. And what's that going to yield? We're going to have 2 is equal to 2 dy dx minus sine y dy dx. Why did we do that? Well, we're collecting all the like terms to different sides of the equation, okay? So the terms with dy dx are like terms, they go on the right, and then any term that does not have dy dx goes on the other side of the equation. All right, so when you collect like terms, now what we're going to do next is we're going to proceed to factor out dy dx from the right side of the equation. So we're going to have 2 minus sine y dy dx. And then to get dy dx isolated, we're going to proceed to divide both sides of the equation by the quantity 2 minus sine y. And then we've achieved the solved state. Let's flip the equation around. We'll have dy dx is equal to 2 over 2 minus sine y. Ladies and gentlemen, that's the answer to question number 6A. Alrighty, let's look at the B part. The B part reads, let me take this out of the way. It says, for negative pi over 2 less than y less than pi over 2, there is a point P on the curve through which the line tangent to the curve has a slope 1. Find the coordinates of point P. Okay, so we want to find the coordinates of the point P where the slope of a tangent line is equal to 1. Alrighty? Okay, so let's go ahead and do that. Now, first things first, we have to know what the slope of a tangent line is symbolically or algebraically, okay? So the slope of a tangent line, the slope of the tangent line algebraically, what does it mean? The slope of a tangent line at x equals a is the same thing as, so let's use Navier-Stiller to help us remember what this means. All right, so slope of a tangent line is the same thing as rate of change and is also the same thing as the derivative. All right, so slope of a tangent line at a point is the derivative at that point. Okay, so in this particular problem, it's going to be dy dx at that particular point, dy dx at x equals a. Okay, or we can just say a comma f of a. All right, which is the same thing as f prime of a. That's what the deal is. So in order for us to solve this problem, we're going to take advantage of the algebraic representation of the slope of the tangent line. So the slope of the tan line, if it is equal to 1, what does that mean? It just basically means that the derivative is equal to 1. Okay, so this means that dy dx is equal to 1. So in order to solve this problem, we want to find the ordered pair, find the point xy where dy dx is equal to 1. Okay, so what is dy dx? It's given to us in the A part. Dy dx, I'm sorry, that's what we found in the A part. When we differentiated implicitly, we had dy dx is 2 minus sine y. All right, so that is equal to 1. Alrighty, now let's just put a side point here. Dy dx is equal to 2. This is a given, okay, over 2 minus sine y. All right, so you can see that this differential equation is dependent only on y. So dy dx 2 over 2 minus sine y equals 1. This will help us to find the y coordinate of the point where the tan line has a slope of 1. Okay, and then we'll find the x coordinate after that. All right, so let's solve this equation, just trig equation. Multiply both sides by 2 minus sine y. We have 2 equals 2 minus sine y. Okay, and then we can subtract 2 from both sides. So we have negative sine y is equal to 0. Divide both sides by negative. We have sine y equals 0. And then to get y by itself, y is equal to the inverse sine of 0. Okay? And from the unit circle, we know that sine is a y-coordinate. So the question is, what's theta value in the given domain, negative pi over 2 to pi over 2, has a y-coordinate of 0? Okay? So let's go ahead and generate our unit circle that satisfies the domain requirements. Just need a little unit circle here, nothing too crazy. Oh, that's not good. We're going from negative pi over 2 to pi over 2. So negative pi over 2 is negative 90 degrees all the way to pi over 2, which is 90 degrees. Okay, bam, there you go. So our constraint, let's make it a little bit smaller. Circle's too big. So let's do it again. Bam, that's good enough. Okay, so from negative pi over 2 down here, which is negative 90 degrees, all the way to pi over 2. All right, so in this interval that we have right here, from here all the way to there, where do we have a situation where the y-coordinate is 0? So from a unit circle, we know that this point right here, this is what? 1, 0. And then if you go down 1, go up 1. This one right here, the x-coordinate is negative 1/2. And, oh, it's actually positive 1/2. So it's positive, now negative root 3 over 2 and 1/2. So let's do that. Positive root 3 over 2 and negative 1/2. Yes, that's it. And then this point right here is root 3 over 2 and 1/2. Okay, and then it just goes all the way to here, and then we know what that point is. Okay, so that's just by the way. But anyway, we already have the answer that we desire. We're looking for where the y-coordinate is 0. So look here, when you have 0 degrees, what's the y-coordinate? We can see that the y-coordinate is 0, right? So that's the desired angle that satisfies this equation. So we know that y is equal to 0. Okay? All right, so there you have it. Now let's go ahead and find the x, since we already know what the y is. Okay? So now we're going to find x where y is equal to 0. So what equation relates x and y? We use the original equation that we had, okay? The original equation that was given to us was 2 times the quantity x minus y is equal to 3 plus cosine y. So we just plug in y here, which is 0. So we have 2 times x minus 0 is equal to 3 plus cosine 0. And then we have 2x is equal to 3. Cosine 0, we can just use it here. You remember cosine is the x-coordinate, okay? Y sin, y is the y-coordinate is sine, and the x-coordinate is cosine. So this unit circle tells us cosine 0 is 1, so cosine 0 is 1, so it's going to be 3 plus 1. And then we have 2x is equal to 4, and then divide both sides by 2, x is equal to 2. Okay, so the point where the slope of a tangent line is 1 has coordinates. What are the coordinates? Has coordinates 2, 0. 2 for the x and then 0 for the y. Alrighty, let's take a look at the C part. Part C says determine the concavity of the curve at points negative pi over 2 less than y less than pi over 2. Give a reason for your answer. Okay, so how do we know the concavity of a function? How do we know the concavity on an interval? Well, let's take a look at our fun charts to help us out. So it's increasing, decreasing. that's f prime, and then we have f double prime, positive, negative, and then f is increasing, decreasing, positive, negative. Okay, so for concavity, concave up or down, we look at the second derivative. Okay, if the second derivative is positive, then it's concave up. If it's negative, then it's concave down. So let's go ahead and write that down. This is a formula that will guide our problem solving process. So this is what we have. If the second derivative, d square y dx square, is greater than 0 or positive, then that means that y is concave up. Okay? And then if the second derivative, d square y dx square, if it's negative, then the graph is concave down. So we're basically looking for the sign of the second derivative to solve this problem. Alrighty, so let's go ahead and do it. So what are we doing here? We want to find the sign of dy dx, nope, d square y dx square, the second derivative, on that interval from negative pi over 2 all the way to pi over 2, and that will tell us the concavity. Okay, all right, so we have the original function, the first derivative, dy dx, is equal to 2 over 2 minus sine y. So we want to find the second derivative, d square y dx square. We're going to use the quotient rule, okay? So this is your v, and then the top is u. So we remember what the quotient rule is. Let's review that real quick. uv prime, u over v prime, is vu prime minus uv prime divided by v square. Okay? All right, let's do it. So in this problem, we're going to have v, which is 2 minus sine y, times u prime, which is 0, minus u, 2, times v prime. So the derivative of 2 is 0, minus derivative of sine y is cosine y. Okay, ladies and gentlemen, we're differentiating with respect to x. So it's still implicit differentiation, right? So when we differentiate cosine y, there's disagreement. I'm sorry, when we differentiate sine y, there's disagreement. Okay, so we have negative cosine y. Now the derivative of, well, let's write it this way so it's not confusing. We're still differentiating this second term right here. So the derivative of sine y is cosine y. Okay, since there's disagreement, we have to add on dy dx. Very important. There you go. Okay, and then in the quotient rule, you can see that in the denominator, it's what we have is v square. Okay, so over v square, which is 2 minus sine y square. Alrighty, so let's simplify this completely. D square y dx square is going to be, so this is times 0, so this is all gone, and then just multiply 2 by this over here, so it becomes positive 2 cosine y dy dx divided by the denominator squared, which is 2 minus sine y squared. All right, so remember, anytime you're finding higher order derivatives implicitly and you have that dy dx component, it should be substituted out, okay? We know what dy dx is. dy dx is 2 over 2 minus sine y, so we're going to substitute that in. So we have 2 cosine y times dy dx, which is 2 minus sine y. Okay, and then this divided by what? This divided by 2 minus sine y square. Okay. All right, so what we can do to simplify, you notice that these two denominators are identical, so we can multiply both the numerator and the denominator by 2 minus sine y. Okay, and then 2 minus sine y. And then what does that give us? We have the second derivative, d square y dx square equals, so the 2, these 2 and these 2 multiply, you have 4 cosine y divided by so you multiply these two, the identical quantity, 2 minus sine y cubed. Okay, all right, now let's go ahead and figure out the sign of this second derivative on the given interval. Alrighty, so to help us out, we're just going to generate our unit circle and look at what's the behavior, what's the sign of sine and cosine on that interval that we are considering, and then we'll work with both of them. All right, so that goes our unit circle right there. Okay, so we're looking from negative pi over 2 all the way to pi over 2, excluding the endpoints. So in this quadrant right here, the quadrant is positive for the x, negative for the y, and then in quadrant 2, quadrant 4 and then quadrant 1, they're both positives. Okay, so what does that tell us? It tells us that let's write it down so we know exactly what's going on here. All right, so remember that x is cosine and y sin. Okay, so we know that from negative pi over 2 to pi over 2 on the entire interval that we have, guess what? The x coordinate is positive, right? Cosine is positive. Alrighty, and then how about, so cosine is positive on that interval? Well, let's break it up. Let's do it halfway, okay? Because there's a sign change there. So let's say from negative pi over 2 to 0. So from negative pi over 2 to 0, cosine is positive because cosine is the x coordinate right here, and sine is what? Sine is negative. Okay, let's label it so it's clear what we're talking about. This is your cosine, and this guy right here is your sine. All right, so we're looking at quadrant 4. That's negative pi over 2 to 0. 0 is right here. Bam. Okay, so with this information, we can determine what the sign of this second derivative is going to be. Okay, so d square y dx, the x square, is going to be 4 times a positive number. Well, let's write down what d square y dx is first. So d square y dx is 4 cosine y over 2 minus sine y to the third. So it's going to be 4 times a positive number. Okay, because cosine is positive in that quadrant, divided by 2 minus, now sine and this interval is negative, right? So it's going to be negative. But you know, in the unit circle, what's the biggest value sine can attain? The maximum value sine can attain is 1. Okay, and the smallest is negative 1. All right, so this number, this sine value right here is going to be negative, but it's not going to be bigger than 1. Okay, so the 2 minus a number, well, it doesn't really matter. We don't even have to work it out because whether it's positive or negative, it doesn't matter. So check this out. It's going to be 4 times a positive number divided by, so this minus and this minus is going to become plus, right? So it's going to be 4 over a positive number. So what is positive 4 over a positive number? It's just going to be positive. All right, so from negative pi over 2 to 0, the second derivative is positive. All right, let's go ahead and figure out what's happening on the other interval. From 0 to pi over 2, we know that cosine is positive and sine is what? Sine is positive also, so they're both positives. So what's the sign of the second derivative going to be? So the square y dx squared is going to be, so we have 4 cosine y over 2 minus sine y to the third. So we're going to have 4 times a positive number, because cosine is positive, divided by 2 minus a negative number. Okay? All right, so let's see what we have here. But the thing is, sine is going to be between 0 and 1. In this quadrant right here, sine is going to be between 0 and 1. So if you compute this difference, no matter what the value is, as long as sine is between 0 and 1, if you subtract it from 2, your sum will always be positive. Your difference, sorry, will always be positive because 2 is bigger than the maximum here. Okay? So it's going to be a positive number on the top divided by a positive number on the bottom, which is positive. So we see that on the entire interval, the second derivative is positive. Okay, so what does that tell us? What conclusion can we draw from it? Well, since the second derivative, the square y dx squared, is positive, is greater than 0 on negative pi over 2 less than y less than pi over 2, the curve is what? What's the concavity? The curve is concave up. All right, we talked about this before. If the second derivative is positive, the curve is going to be concave up. So there goes the answer to 4C. All right, let's take a look at the last part. It says let y equals f of x be a function defined implicitly by 2 times the quantity x minus y equals 3 plus cosine y that is continuous on the closed interval 2 to 2.1 and differentiable on the open interval 2 to 2.1. Use the mean value theorem on the interval 2 to 2.1 to show that 1 over 15 is less than or equal to f of 2.1 minus f of 2 less than or equal to 1 over 5. All right, so let's get started by stating the mean value theorem. That's what we're going to be using here. Formula is as follows. So according to the mean value theorem, what do we know? So using the mean value theorem, we know that there's going to be a C by the MVT. There is a C in AB where, so the function is continuous on the closed and differentiable on the open. There's a C on AB where the slope of the tangent line f prime of C is equal to the average rate of change, f of B minus f of A divided by B minus A, okay? All right, so this is what we're going to use to solve this problem. So to get us started, let's identify what our A and B are. Alrighty, so what is A and what is B? Well, we'll just look at the interval that tells us what A and B are going to be. So the lower bound on the interval is your A and the upper bound is your B. So our A is what's our A? Our A is 2 and B is 2.1. All right, so based on the conclusion of the MVT, there is a C. There is a C in this open interval where what? F prime of C is equal to, this is the slope of a tangent line. The rate of change is equal to the average rate of change, f of 2.1 minus f of 2 divided by 2.1 minus 2. Okay? All right. All right, there's a piece of information that we're given that we haven't utilized yet. So let's put that on the side here. In this problem, we're given a piece of information, which is that 2/3 is less than or equal to dy dx, and that's less than or equal to 2. Okay, dy dx is the same thing as f prime of x, right? Okay, so using this piece of information, we can start creating our inequality. Okay, so we know this is given since 2/3 is less than or equal to f prime of x, and that's less than or equal to 2. This is a given. We can carry out this substitution, okay? We can plug in since f prime of c is a particular c value that we're looking at here, we can take this expression and substitute it in the middle. So by substitution, what do we have? By substitution, we have 2/3 as less than or equal to, instead of f prime, we're going to put the symmetric difference here, f of 2.1 minus f of 2 divided by 2.1 over 2.1 minus 2, and that's less than or equal to 2 by substitution. Alrighty, so let's simplify this a little bit. So we have 2/3 is less than or equal to f of 2.1 minus f of 2. 2.1 minus 2 is 0.1. Okay, so less than or equal to 2. Now let's write this as a fraction so we can finish this off easily. So what is 0.1 as a fraction? 0.1 is 1/10. Right? So it automatically tells us what we need to do. So we're going to write 0.1 as its fractional equivalent, which is 1/10. Okay, so we have 1/10. Oh boy, I changed my color. Okay, so to get rid of this fraction in the bottom, we just multiply the three sides of my equation by the reciprocal, by 1/10, not the reciprocal. All right, so this is a compound inequality, so we're going to multiply the middle by 1/10. Okay, if I multiply the middle by 1/10, that cancels that 1/10 right there, and then we multiply this by 1/10, and then we'll multiply the left side by 1/10 also. Alrighty, and then if we simplify that, we are going to have on the left side 2 goes there, 2 goes there, 5. That'll be 1/15 is less than or equal to, and then the denominators cancels out in the middle of the inequality. 110 and 110 cancels out, so it's f of 2.1 minus f of 2, and that's less than or equal to on the right. 2 goes there, 2 goes there, 5. 1/5. Ladies and gentlemen, we've been able to show that this inequality is in fact true based on the information given. Okay, so that's what we're asked to show in the initial problem. Show that this inequality is true, and we've been able to show this using the mean value theorem. Thanks so much for taking the time to watch this presentation. If this tutorial was helpful in your preparation for the AP Calc exam, do give us a like or a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel. We upload videos to our page on a regular basis, so subscribe so you can get notifications of those updates. If there are any questions or special requests that you have concerning AP Calculus, just place it in the comment section below, and we'll be more than glad to assist you. More support resources can be found at mathgotserved.com. Go ahead and check it out. Thanks again for watching, and have a wonderful day. Goodbye.